All right, in this video, we're going to be going over their transformation review assignment. Remember, they're not going to match up exactly, but there should be some similar examples that you can use to help you out. So let's go ahead and figure out number 1. So it says to draw the following quadrilateral after a translation of 1 unit to the right and 4 units up. So remember what that means is I'm just going to take each point and slide it. So 1 unit to the right and 4 units, 1, 2, 3, 4. So this point moves here, this point moves 1 unit right, 1, 2, 3, 4. So far, this is my shape, 1 unit to the right, 1, 2, 3, 4. And 1 unit to the right, 1, 2, 3, 4. Now remember to use your line tool in order to connect these shapes. So here's my new shape. All right, let's move on to translation rules. So it says that the figure to the right is translated the following 6 units to the right and 9 units up. So notice D and D with apostrophe is just prime. It's telling you where it's moving. The one with the little apostrophe is the second shape. So it says it's taking D and putting it from -5, -2, to +1 is my new quadrant, X value, and 7 is my Y value. I'm going to move each of those. E moves to the ordered pair 5, 8, and F moves to the ordered pair 4, 3. Now it says what is the rule that's transforming these? Now all of this is saying is if I notice a pattern going from the X to the new X and the Y to the new Y, what's happening with those values? So go from -5 to 1, is it subtracting by 6? Well, no, it's getting bigger, so that option is out. From this one to this one, is it saying, is it taking the X value -9 and timesing it by -5 and timesing it by -9? No. Well, what is it doing? To go from -5 to 1, it's adding 6. To go from -1 to 5, it's adding 6. To go from -2 to 4, it's adding 6. And we can see right here where it says 6 units to the right. Well, that makes sense. When we move something to the right, it gets bigger by 6. So this option, this last one that says the X value is adding 6, and it says that 9 units up, if you look at the Y values, -2 to 7 is up 9, -1 to 8 is up 9, and so on. That last one's my correct option. So we're just looking literally right here. 6 units to the right means I'm going to add 6 to the X values, and up units means I'm going to add 9 to the Y values. And if it had been down instead of up, it would have been subtraction. If it had been left instead of right, it would have been subtraction as well. The next problem asks me to reflect across the x-axis. Remember, here's my line of reflection, and we're just counting how many spaces and then going directly the opposite. So this dot right here is 1, 2, 3, 4 units away, so I'm going to go 4 units in the opposite direction, 1, 2, 3, 4. This point is 1, 2, 3 units away, so I'm going to go 1, 2, 3. And last but not least, this unit is 1, 2, 3, 4, 5, 6, 7, 8. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8. Make a dot, and there I have my reflected shape. Now rotating something 180 degrees, and rotations are a little bit trickier. Sometimes we like to rotate our head. One rule that I want to make sure that you know is if I take any of my X and my Y values and I rotate it 180 degrees, well, what quadrant is that going to end up in? 1 quadrant, 2 quadrants. So 180 degrees is 2 turns. So my triangle is going to end up here. Remember, in this quadrant, all of the X values are negative and all of the Y values are positive. So that's something that I can use to make sure I have my right answers. I like to use my rule. So if I rotate it 180 degrees, that means the X and the Y value are going to stay the same, but they're going to take on this negative and positive. So I'm going to see all negative X values and all positive Y values. But I'm still going to use the same X and Y. So for example, this point right here is at 2, -1. So when it rotates, I'm going to keep the same X value, which is 2, but I'm going to make it negative. So I have -2, and now even though this says positive and So that because it says positive y, I'm going to take this positive negative 1 and change it to a positive. So my first dot is going to be at -2, +1, and so on. This point right here is at -5, -4. So when I use my rule, I'm going to make sure I still use a -5. Sorry, this was a +5. My goodness. I'm going to use a -5, and the y value is positive, so +4. So -5, +4. And last but not least, this point is a 1, -3. So when I translate it, I'm still going to use 1 and 3, but the 1's going to be negative and the 3 is going to be positive. So -1, +3. So there is my triangle rotated 180 degrees. Well, let's talk about rotating something counterclockwise. So when I rotate something counterclockwise, and in order to rotate the shape, I'm just going to rotate the two endpoints, and then I'm going to make my line shift. So if I'm rotating counterclockwise 90 degrees, that means this point is going to end one quadrant, is going to end up in this quadrant, and this point's going to end up in this quadrant. So keep in mind a couple things about 90-degree turns. With 90-degree turns, I take my X and Y and I flip-flop them. And I'm going to take whatever positive or negative is in these quadrants. So if I'm rotating this point right here, and it is at a -1, +5, that means when I move it to this quadrant, I'm going to flip-flop them. So I'm going to have 5 and 1, and then I'm going to think about this quadrant down here. Remember, this quadrant down here is a negative quadrant, all the X values and all the Y values. So I'm going to use -5, -1, and I'm going to plot that point in a different color. So -5, -1. And on this point right here, it is at 3, 2. So my rule is to switch them. And then what quadrant is this? This X values are negative, Y values are positive. So -2 and +3. So -2 and +3. And there's my shape rotated 90 degrees. So again, quick rule. So for 180, the X and the Y stays the same. For 90 degrees, clockwise, counterclockwise, or 270, you switch the X and the Y, and you pay attention to what quadrant it's going. Okay, the next problem is asking me to work with dilations. So if I'm doing a dilation with a scale factor of half, that means all of these points are going to be shrunk. So this is at, right now, it's at 10/6. So half timesing by half, timesing by half. Half of 10 is 5, half of 6 is 3. So this point right here, and we'll change colors, is going to move to 5, 3. This point right here was at 12, 10, half and half that, so that's going to turn into 6, 5. For this last point that I have at 8, 12, half of 8 is 4, and half of 12 is 6. So my last point's at 4, 6. So there's my new shrunk shape. Okay, last couple problems are going to be going back over telling if something is congruent and then identifying the transformation. So A and B, 1, 1, 2, 2, 3, 3. Yep, they are congruent. What transformation occurred to go from A to B? Well, from A to B, it looks like it just slid. So translation and down 8 units. I'm just going to double check the 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that bottom corner to bottom corner is down 8. Next shape, are these congruent? 1, 1, 2, 2, 3, 3. Yep, they are congruent. Now, what it looks like it happened, it didn't just slide into that quadrant, it turned. Okay, and what direction did it turn? We have two options. 90 degrees counterclockwise, 180. Well, only moved one quadrant, so 90 degrees counterclockwise. On this problem, we are checking to see, number 1, are they congruent? 1, 1, 2, 2, 3, 3. Okay, so yes, they are congruent again. Now, what transformations? There's more than one. So it didn't just flip over this axis. It maybe flipped and turned, okay, or maybe it slid or rotated and then flipped. We just got to figure out which of those options works best for us. So let's go ahead and pick. So first option says translate up 6 units and then rotate 180 degrees counterclockwise. So if I move up 6 units, move this up 1, 2, 3, 4, 5, 6. So my shape looks like this. And then rotate 180. Well, is it going to end up, and then counterclockwise, is it going to end up in the right quadrant? 1, 2. Yes. Well, let's go ahead and just quickly check to make sure that at least one of my points holds. So if I look at this point right here, and I know it needs to rotate 180 degrees, remember, since this was -5, 2, when I rewrite my point, I'm going to reuse that 5 and the 2, but I need to use the ordered pair like rules for this quadrant. So all of the x values are positive and all the y values are negative. So I'm going to make the 5 a positive and the 2 a negative. And sure enough, that's where my point is right there. If I check one other one just to be sure, that says -3, 4. So when I write my new point, I should have 3, 4, and then I want the 3 to be positive and the 4 to be negative. So +3, -4. Sure enough, 2 of those points line up. So I'm going to go ahead and just select that. It does say choose all that apply, so I want to quickly make sure that none of the other ones also apply. So it says translate the figure up 8 units and then reflect it over the y-axis. So quick picture of where that goes. It goes up and then over this axis, so it should be over here, and it's not, so X that one out. The next one says reflect it over the x-axis and then rotate it 90 degrees. So flip it over the x-axis, so it's going to end up in this quadrant right here, and then rotate it 90 degrees clockwise. So if I rotate it, it'll end up in this quadrant right here, which is also a no-go. So a lot of these can be eliminated just by where it should end up. The next option says rotate at 180 degrees counterclockwise. So if I rotated at 180 degrees counterclockwise, it would end up in this quadrant, and then reflect over the y-axis. So it should flip over the y-axis to over here, which it's not even close. So we know, and we know it is option A, so I'm going to select none of these. I am not going to select none of these. Cross that out. All right, let's choose our last one. So again, these aren't congruent, but these do look kind of similar. And if I look at it, figure A to figure B, it's getting smaller. It goes from 2 to 1 and 4 to 2, so it's getting smaller by half. And wouldn't you know, all of these say scale factor of half, so perfect. We're going to just quickly jump through all of these. So the first one says it reflects over the x-axis and then dilates. So it does kind of look like it flips, and it does shrink, and it should get closer to the x-axis. I'm going to keep this one in mind. I'm going to just maybe cross out some of the obvious no's. So the next one says it flips over the y-axis and then dilates, so that's an obvious no. And the next one says rotates 90 degrees counterclockwise. So it does end up in the right quadrant, but remember, it needs to turn 90 degrees. So this length right here should be 90 degrees from the original. So not this option, that one's out. The next one says dilate it, then translate it. So it does look dilated, but translated would just mean it would slide. So this big long side should be up, and it's not. So this is another obvious no. So I'm going to just double check this top one before I click none of these. So it says flip it over. So if figure A, it would flip down to here. This point would flip to here. So let's just check those two to make sure they went to the right places, and I think we can agree. So 2, 2, and it had a scale factor of a half. So 1, 1. Half of 2 is 1, half of 1 is 2 is 1. This is 8, 2. Half of 8 is 4. Half of 2, is 1. So this point's at 4, 1. And this one's at 1, 1. So yes, I would agree with that. So selecting that top option, are they similar? Yes, they are. All right. If you have any questions, please reach out, let me know, and good luck.